Hello. So in this particular slide, we see how an electromagnetic waves are produced. So you see that there is a wave propagation here. And as I explained earlier, the wave is traveling in the X direction. The component of electric field is in the Y direction in the blue color, and in the Z direction, in the Z plane, you have a component of magnetic field, and it is, you see, in the positive Z and the negative Z, the magnetic field is there, and positive Y and the negative Y, we have a components of electric field. And in the X direction, the wave is radiating through the space. And we say that electric field and the magnetic field, they are orthogonal to each other, and they are also perpendicular or orthogonal to the direction of propagation. So now the question here is how this EM waves, electromagnetic waves, are produced. So basically we see that, let's say we have a charge. It could be a positive charge or negative charge, and we know that it is surrounded by an electric field and a magnetic field. So when this charge is stationary, I am saying stationary, it means it is not moving. So the EM waves, the components of electric field and a magnetic field surrounded by it, remains stationary. But let's say I move this charge in a certain direction. So it is moving in a direction. So when it is moving, or in other words, when it is accelerating with a certain speed and a certain direction, then these EM components, electric field and magnetic field, gets disturbed, surrounded, which is surrounded to this charge, is get disturbed, and it starts moving along with these charges. So that's why we say that EM waves, that they are produced when the electric charges are accelerated. So where is the electric charge? Let's say, for example, we have negative electrons or negative charges, and we know that if there is a current carrying conductor, and when say that the current I is traveling through a wire, a piece of wire, this is, let's say it's a current carrying conductor or a piece of wire, it is also called as, it acts as an antenna. So when the charges are moving with a certain speed and in a certain direction, it is, we say that the EM wave is traveling through this wire, okay, or through this antenna. So electromagnetic waves, they are produced by AC, when an AC current flows through a wire and antenna, okay. So, and the frequency of that EM wave that will be reduced in this wire, the frequency that is, so in this picture, we say that the EM wave has been produced, and the frequency of that is equal to the frequency of this AC current. So whatever the frequency of this AC current that is traveling here through the wire is nothing but a frequency of the EM wave that got produced due to the charge movement. Okay, so remember, when the charges are stable, stationary, in a static position, EM wave, which is components of electric field and the magnetic field surrounded by this, is also stationary. But when the charge gets moved, let's say I basically move this charge in a certain direction with a certain speed, the EM components, electric and magnetic field component, get disturbed and they start radiating.